For decades, astronomers have pointed massive radio dishes at the night sky, hoping to intercept a message. Most of the time, they record the natural, quiet background hum of the cosmos. Occasionally, human technology creates a distraction. Take the peritons at the Parkes Observatory in Australia. Scientists tracked these mysterious millisecond-long radio pulses for years, only to eventually trace them to a microwave oven in the staff kitchen being opened prematurely. These deceptions continue even with modern equipment. In 2024, the ASCAP telescope array detected a 30-nanosecond radio pulse so powerful it outshone every other cosmic source in the sky. When researchers pinpointed the origin, they found Relay 2, a dead NASA satellite launched in 1964. It had built up static electricity over 60 years and released a single massive discharge. Separating earthly interference from genuine cosmic events is an exhausting daily reality for radio astronomers. This baseline of constant skepticism makes the events of August 1977 entirely unique. This schematic shows the Big Ear Observatory in Ohio. Unlike a traditional dish, it was a flat-pack-style telescope that couldn't pivot to track a target. Instead, it relied entirely on the Earth's rotation to sweep its sensors across the sky. Days after a routine observation run, astronomer Jerry Amon reviewed stacks of computer printouts. He was scanning through endless columns of low numbers, representing the normal background noise of space. This is the actual printout Amon was reading. Buried in the data is an anomaly, the sequence 6EQUJ5. That string indicated a radio burst 30 times stronger than background space. Amon grabbed a red pen, circled it, and scribbled a single word in the margin. The burst was exceptionally intense, but its frequency was the true anomaly. It was broadcasting precisely near 1420 MHz. 1420 MHz is the natural emission frequency of neutral hydrogen, the most abundant element in the universe. Physicists have long theorized that a technologically advanced civilization would use this exact frequency as a universal hello. The data hit every theoretical requirement for an intentional extraterrestrial broadcast. It effectively launched a 50-year scientific cold case to find a definitive cause. To rule out an earthly origin, like a passing airplane or a kitchen appliance, researchers analyzed the signal's exact 72-second duration. Because the Big Ear telescope was bolted to the ground, its observation window was strictly limited by the speed of Earth's rotation. A transmission originating from deep space would gradually increase in strength as the telescope rotated into its path, peak at the center, and fade out. That geometric sweep takes exactly 72 seconds. The WOW signal perfectly matched this profile. Over the decades, astronomers chased several dead ends. A 2017 theory suggesting the signal came from a passing comet's hydrogen cloud was eventually dismissed because it failed to account for the telescope's beam dynamics and the lack of a secondary signal in the telescope's twin sensor. The ultimate test came in 2022. The Breakthrough Listen project pointed the Green Bank telescope at the exact coordinates in Sagittarius where the signal originated. They found no technosignatures. There were no signs of alien activity or intentional broadcasts of any kind. The 72-second sweep proved the burst came from deep space. The lack of repetition proved it was not an intentional message. Scientists were forced to look for a completely natural mechanism capable of generating a narrowly focused, one-time radio beam. Professor Abel Mendez and his team at the Planetary Habitability Laboratory recently reanalyzed 50 years of archival data from the Arecibo Observatory in Puerto Rico. In the Arecibo archive, Mendez's team identified several faint, narrow-band signals clustered near the hydrogen line. These signals matched the signature of a natural mechanism that had been hiding in the data for decades. Mendez proposed the astrophysical maser theory. A maser is essentially a microwave equivalent of a laser. Creating one in deep space requires a massive, freezing cold cloud of floating neutral hydrogen gas. The second requirement is a trigger. Directly behind that cloud, you need a magnetar, a violently magnetic, incredibly dense dead star. Magnetars are prone to massive starquakes. When one erupts, it unleashes a radiation flare. If that flare slams into the hydrogen cloud at the right angle, it forces the cold hydrogen atoms into a highly energized, synchronized state. The gas cloud acts as an interstellar magnifying glass, releasing all that absorbed energy at once in a hyper-concentrated, narrow-band radio beam aimed straight into the void. The wild signal is likely the first recorded instance of a colossal interstellar space laser, perfectly aligning with an antenna in Ohio. Losing the alien hypothesis might feel like a romantic disappointment, but this natural explanation provides a detailed new insight into the behavior of the most extreme objects in space. It arrives alongside other recent discoveries, like the detection of RB float. This fast radio burst, an incredibly powerful flash of radio energy, is the closest and brightest one ever found, originating 130 million light-years away. When scientists pointed the James Webb Space Telescope at RB float's exact location, they found an unexpected infrared signal. Like the WOW signal, it doesn't repeat. It challenges our current models for how these bursts behave. Magnetar-triggered masers and explosive fast radio bursts reveal a cosmos that is intensely chaotic. Deep space is continually generating focused energy anomalies that break the rules of conventional physics. 50 years of listening has revealed a cosmos far louder and more chaotic than we once imagined. We are finally learning to translate the explosive, natural language of the universe itself.